Hey guys, happy Tuesday. Yesterday we talked all about exponential functions, what those look like. There's a little bit more that we want to add to that today. I want to talk about domain and range. What are those going to look like? I want to talk about, like the basic formula, like slope-intercept form for linear, but this is, obviously not stuff that's linear, right? So, first off, quick recap. We talked about how these graphs that are exponential are going to look something like this, right? And I did want to mention to you guys that you can, there are shifts, there are ways to make it go steeper, right, and stuff like that. There's a way to flip it. We're going to talk about all that kind of at the end, all the shifts and stuff like that. But for now, we talked about this horizontal asymptote, right, and what that does, and how this point is 0, 1, right, and the basic function, stuff like that. But what about domain and range? So our domain, our x values here, we talked about this a little bit, but there is no restrictions. Let's say this is y equals 2 to the x. That's what we talked about yesterday, right? There are no restrictions to what we can put in here for x, right? We're allowed to put negatives in there. We can put positives in there. We can put 0 in there. We talked about what all those spots are going to look like. So our domain is going to be negative infinity to positive infinity. Or if you want to write all real numbers there, right, that's totally okay too. So there's nothing that restricts the x values here. Now what about the y's? Those are going to work a little bit different, right? This is where our horizontal asymptote is going to come into play. We said that there's no way that this graph could reach the x-axis, right? There's always going to be some sort of horizontal asymptote that's going to kind of restrict our movement. So for our range, the only y values could be above the x-axis. So if we want to write that, there's two ways we could write that. We could do from 0 to infinity. We're talking about y values here, right? And we're not including 0. That's why we have the soft parenthesis here. Or, which might be better for you guys, we can write that as where x is strictly, y, because we're talking about range. Y is strictly greater than 0. Right? So the range is going to be restricted on all exponential functions. There's something that's going to be a problem. So every time that you find domain and range, the domain shouldn't matter. It should always be negative infinity to positive infinity, pretty much, as long as it's not a piecewise or something like that. And, we're not going to be able to restrict the x's here. However, the range is going to give us that problem. So our asymptote might not always be right on the x-axis when we start shifting this thing around. But for now, for like the parent function, if you want to think of it that way, it is. So our y values have to be greater than 0. They can't be greater than or equal to either, because it's never going to actually touch 0. Awesome. So that was one thing I wanted to talk about today. Secondly, we talked about slope-intercept form, obviously, quite a bit, right? When we talked about stuff that was linear. So the exponential form, which I don't think really has a fancy name or anything, is going to look like this. We're going to have a b to the x. And this b is probably in parentheses like that, right? So let's kind of dive into this a little bit and talk about what we're seeing. This b is our base, right? What number has the x as an exponent on it? And that number, just a quick recap, right? This will tell us if it's growth or decay. Right? If it is greater than 1, we know that it's going to be growth. If it's between 0 and 1 and a fraction, we know that's going to be decay. So that number tells us some interesting information, right? This a value, though, we didn't really talk about yesterday. This is, this number, I should talk about this base. The base is sometimes called a constant ratio. And let me talk to you guys about what that means when we say constant ratio. That's kind of like our slope. Obviously, we would only use slope if it was linear, but that's the idea. This is the number that's going to tell me how it's changing. So if you guys remember in our table yesterday, I'm going to use 2 to the x again. We said something like this, right? It was 1/4. Here we go. Okay, we said that if you looked at this table, we're not adding the same number every time like we were when it was linear. We're multiplying. So to get from here to here, we multiply by 2. Multiply by 2, multiply by 2, multiply by 2, multiply by 2. That is because this number right here, the constant ratio, the base with the exponent, is 2. If we were to change that to, let's say, y equals 8 to the x, in this table, what I would expect to see is that we're multiplying by 8 each time we move down. So that's going to give us our idea of how this thing changes. It's not quite slope, but we're going to multiply by that number every single time in the y's. That's going to be what's going to show us the change here, right? So, or if you work backwards in the table, it'd be like divide, right? You divide by 2, divide by 2. If it was the base was 8, the constant ratio, that's going to tell us we multiply by or divide by to go backwards. This a value here, this is our initial value. So I sometimes just slip and call it the y-intercept. It is the y-intercept. Really, y-intercept is kind of a, we think of it as like a linear term, but you can always have a y-intercept. That's where it's going to cross the y-axis. Because, take a look with me here, when x is 0, look at what that's going to do. B to the 0 is 1. 1 times a is just a. So this number, if there's a number out in front that we're multiplying this constant ratio by, that's going to tell me my starting point, my y-intercept, my initial value. Okay? So let's, that's general, right? Let's look at specific. So let's say I gave you something like g of x equals 3 times 4 to the x. Without graphing this thing now, right? We've talked about it for what, 2 days? We kind of know what this is going to look like. We know some information about this thing. First of all, I can tell you that it's exponential growth. Because the constant ratio in there is bigger than 1. I also know that if x was 0, 4 to the 0 is 1, 1 times 3 is 3, this number here is going to tell me my y-intercept. So I can make like a sloppy copy graph, which is kind of nice. I don't know if this is accurate to say or not, but I feel like as you get older in math and you're learning more, the less accurate your graphs kind of have to be. Because we kind of learn shapes. Like, this is what this is going to kind of look like. And then usually that's good enough, which is really cool. Obviously, if it was linear, I'm looking at every point that you plot on the graph. But on this one, let's look at key features. I know it's going to go up. I know that it's going to cross the y-axis here at 3. And we haven't learned about shifts at all, but I'm going to tell you that we didn't shift this thing at all. So that means that it's still going to have a horizontal asymptote on the x-axis. So kind of what this is going to look like, and 4 is going to go up a little bit quicker than 2 did, right? Kind of what this thing is going to look like is we have this, and then it goes up, and there's our exponential function, right? Look at our key features. It's increasing. It's exponential growth. Here's our horizontal asymptote, and it's crossing at the point, the y-axis at the point 0, 3. And those kind of things, that's enough to gain from this information to piece together a really nice picture of like, hey, this graph kind of looks like this. So, talked about domain and range. Cool. And we talked about this initial value and this constant ratio and what those two things are bringing to the table and telling us about these functions. I think that's pretty good. You guys should have a pretty good grasp of what's going on with these exponential functions now. Cool. All right. I'm going to, upload this and watch the Buckeye game. Hopefully tomorrow I'm still smiling. Go Bucks, and we'll see you guys later.